Okay, today topic is thyristor commutation. Okay, so in last class we discussed triggering of thyristor. Triggering of thyristor means how you can turn on the thyristor. So how you can turn on the thyristor. So different methods we have learned in last class. Today thyristor commutation means how thyristor will be turned off. So by using these some commutations, we have turned off the SCR. Okay. So thyristor commutation. So commutation means process of turning off a conducting thyristor. Okay, so to turn off the thyristor, so commutation process will be used. Okay, so in commutation process we have current commutation and voltage commutation. Okay, so current commutation and voltage commutation. So a thyristor can be turned on by applying a positive voltage of about volt or current of a few tens of milliamps at the gate to cathode terminal. Okay, but SCR can't be turned off. Why is the gate terminal? Why the gate terminal? It will be turned off only after the anode current is negated either naturally or using forced commutation technique. Okay. So these methods of turning off do not refer those cases. So where the anode current is gradually reduced below the holding current level manually or through a slow process. Once the SCR is turned on, it remains on even after removal of a gate signal as long as a minimum current, the holding current, is maintained in the main or rectifier circuit. Okay. So commutation means turning off a conducting thyristor. So to turn off the conducting thyristor, we are using commutation technique. So commutation techniques also current commutation and voltage commutation. So a thyristor can be turned on by applying a positive voltage of about uh, volt or a current of a few tens of milliamps at the gate to anode terminal. But SCR can't be turned off via gate terminal. So SCR we can't turn it off by using gate terminal. So it will turn it off only the anode current is negated or either manually or by using forced commutation techniques. So when thyristor will be turned off means whenever the anode current is negated or negated either naturally or by using forced commutation techniques. Okay. So the method of turned off do not refer those cases where the anode current is gradually reduced below the holding current level manually or through a slow process. Okay. So once the SCR is turned on, it remains on even after removal of a gate signal as long as minimum current of holding current is maintained in the main rectifier circuit. Okay. So thyristor turned off mechanism means in all practical cases negative current flows through the device. This current returns to zero only after the reverse recovery time TRL when the SCR is said to have regained its reverse blocking capacity. Okay. The device can block the forward voltage only after further TF for the forward recovery time has elapsed. Continuously, the SCR must continue to reverse biased for a minimum of time taken for reverse blocking reason and reverse recovery time is equal to rated turn off time of the device. Okay. So the external circuit must be before reverse bias. The SCR for a time of so T of time is greater than TQ. Okay. Subsequently, the replied forward biasing voltage must rise at the dV by dt is less than or equal to dV by dt repelled rated. So this dV by dt is less than the static concept. Okay. So here we have to see a diagram. So this is thyristor turned off in the time. At first the current at first the current will be at high position. Whenever the current will goes 0 and here will be reverse recovery recovery blocking region is there. So reverse leakage current will flowing. After slowly the current will be reducing zero. So the current from in reverse blocking region will increasing and decreasing. So this is called reverse recovery time. And after reverse recovery time, the current will be going to zero. This is called forward region. And total time will be TQ. Okay. So next. So thyristor commutation will be classified into two types. So natural commutation and forced commutation. Discussed natural commutation and forced commutation. Okay. So commutation techniques of thyristor. So commutation is defined as the process of turning off a thyristor. So I already tell na. So turning off a thyristor is mainly bringing the forward conduction mode. So turned off means the thyristor will bringing the forward conduction mode. So to forward blocking mode. Okay. So turning off purpose of thyristor is required. Anode current to be reduced below the holding current. Application of the reverse voltage. So application of the reverse voltage remains this extra. So extra charge of current. Okay. So next classification of commutation will tell na. So commutation techniques of thyristors are classified into based on the manner in which the anode current is reduced to zero and the configuration of your commutation circuit. So how you can reduce the anode current zero and the configuration of commutation circuit. Okay, by using these two techniques, the commutation will be classified: natural commutation or line commutation. So we have called natural commutation or line commutation, and load commutation or self commutation, and forced commutation. Okay. So in natural commutation or line commutation, and load commutation or self commutation, forced commutation. So natural commutation or line commutation, and it is also called class F commutation. So load commutation or self commutation, this is called class A commutation. And in forced commutation we have class B commutation, class C commutation, and class D commutation. Okay. So we have discussing natural commutation or line commutation. So natural commutation or line commutation, and this is also called class F commutation. Okay. So the thyristor, whenever we are giving a thyristor to the thyristor will be connected to a resistive load. So here voltage will be applied in sinusoidal voltage. Okay. So natural commutation of thyristor occurs when the supply is that nature of a supply automatically take care of a commutation. So it is known as natural commutation or line commutation. So natural commutation, we don't use any technique. So the latching, the anode current will comes to zero naturally. Okay. So when supply is as AC, then the anode current through the thyristor automatically pass through zero of the at the end of the result. Okay. So we are seeing here we have to seeing a commutation. So this is a commutation. So we are using sinusoidal wave. Okay. In sinusoidal wave, at first the thyristor will be turned on. Okay. So thyristor voltage turned on. In negative side, there is no voltage will be flowing, and after that, whenever sinusoidal will be going, then again the voltage will be increased. So VT means thyristor voltage. So this is load voltage, and thyristor voltage means, so thyristor will be conduct in reverse bias condition. Okay. So this is natural commutation. So natural commutation applications will be used in phase control conversion, line commutated inverters, AC voltage controller, and step down cycloconverter. Okay. So natural commutation techniques will be used in phase control converter and line commutated converter, AC voltage controller, and step down cyclo converter. Okay. So the anode current becomes zero after a positive half cycle. Okay. So the supply voltage also applied to a reverse bias. So voltage across the SCR in negative half cycle, this is a reverse bias. So consumes that SCR region, it's a blocking capability. Okay. So next, load commutation or self commutation, and this is called as class A commutation. Okay. So load commutation or class A commutation is the possible in thyristor circuit supplied from DC source. It is not possible in AC circuit. Okay, so class A commutation is only possible in DC source. Okay, for load commutation to occur, the nature of a latching, nature of the circuit should be such that when it is encouraging from DC source, so the current has a tendency to decay to zero value, okay, due to load. So it is possible when the load contains RLC parameters and satisfies the under-damped condition. So load commutation or self commutation we called as class A commutation, and it is used in DC circuits. Okay, so load commutation will be possible when the load is resistance, inductance, or capacitance. Okay, so and also to satisfy under-damped condition. Okay. And next, this is load commutation circuit. Here we are in thyristors will be connected inductor, capacitor, and resistor. So when the circuit is encouraged from DC encouraged, the current first rises to maximum value and then decay to zero. So first current rises to maximum value and decay to zero. Okay. So thyristor gets turned off, voltage of a capacitor applies to reverse bias across a thyristor after the turning off. So here, so load commutation is also known as resonant commutation or self commutation. So load commutation will have another name, resonant commutation, and also self commutation. Okay, so load commutation will be used in series inverter circuit. Okay. So these are the waveforms. So when if we have to use it in current IT, so load current decays to zero because of under-damped LC circuit. Okay, so during this LC circuit only the current comes to zero. Okay, so the voltage across the load will be increasing to 2 Vs. Okay, and next. So load current is likely charging current of a capacitor. So initially after turning on a thyristor, current IT increasing, then it reaches to maximum value and then decays to zero. So at omega 2 equal to pi, when the thyristor current decays to zero, the voltage forced in a capacitor 2 Vs. So at omega t equal to pi, voltage across this thyristor Vt equal to 2 Vs. Okay, so conduction angle of thyristor means omega t 0. So that is pi. So at pi the current comes to 0. Okay. So conduction time of thyristor Tn equal to pi by omega. Here omega naught is known as resonant frequency. Okay. So of the LC circuit, resonance frequency of LC circuit equal to 1 by root LC. So conduction time T naught equal to pi by omega. So here omega equal to 1 by root LC. So that means pi root LC. So at load commutation, the conduction time equal to pi root LC. For satisfying the condition under damping, so R by 2 is less than root LC, or R square is less than root LC. Okay. So next, forced commutation. Okay, forced commutation, when supply is DC, natural commutation is not possible because of a polarity of supply remains unchanged. So when supply is DC, natural commutation is not possible. Okay. Natural commutation is not possible because of the polarity of supply remains unchanged. Hence, special method must be used to reduce the SCR current below the holding current value or to apply negative voltage across the SCR at a time of interval greater than the turn off time of SCR. This technique is called forced commutation technique. All circuit where the supply voltage is DC. So chopper, inverters, we have to use it in forced commutation techniques are as follows. Okay. So we have natural commutation techniques and load commutation technique. Okay. And forced commutation technique. In natural commutation technique, we don't use any force to anode current comes to 0. So whenever the naturally the current, the SCR current will comes to 0. Okay. So in load commutation, by using RLC load, we have to the SCR current will be turned on by using RLC circuit. Okay. In forced commutation, so in to turning off a thyristor, so specially another force will be used. So that is why we are using forced commutation. So forced commutation mainly used in choppers, okay, inverters, okay, choppers and inverters. Okay. So forced commutation when used means so SCR current below the holding value are to apply negative voltage across the SCR for a time interval greater than the turn off time. So the holding current value will be greater than the turning off time of SCR. Then we have to using forced commutation. Okay. So in forced commutation, we have self commutation, resonant pulse commutation, complementary commutation, impulse commutation, external pulse commutation, load side commutation, and line side commutation. Okay. So in forced commutation, in forced commutation technique, we have 7 commutation techniques are there. Okay. So self commutation technique and resonant pulse commutation techniques and complementary commutation technique and impulse commutation technique and external pulse commutation and load side commutation and line side commutation. First we have to discussing self commutation. Okay. So self commutation or load commutator or class A commutation. So commutation by resonating the load. Okay. Commutation by resonating the load. So in this type of commutation, the current through the SCR is reduced below the holding current value by resonating the load. So in this self commutation, the current through the SCR is reduced below the holding current value. Below the holding current value by resonating the load. So by resonating the load, the holding current will be reduced. Okay. So the load circuit is so designed that even though the supply voltage is positive, an isolating current tends to flow, and when the current through the SCR reaches to 0, the device is turned off. This is done by including an inductance and capacitance in series with the load and keeping the circuit under damped. So this type of commutation used in series inverter. Okay. So you have to drawing this is self commutation circuit. Okay. So this is thyristor. So the thyristors will be connected resistance, inductance and capacitance. So whenever we are giving supply, the current will be flowing from thyristors to load, inductor and capacitor and coming to this after. So this is circuit diagram for self commutation. So we have expression the current at t equal to 0 at the time of when the SCR turns on. The applications of gate pulse assume the current in the circuit is 0. So 0, and the capacitor voltage VC is 0. Okay. So writing the Laplace transform circuit in the figure. So following circuit obtain the SR. So the current is flowing through thyristor and resistance and inductance and capacitance. Here Vs by S. There is a positive polarity will be there. Okay. So we have to calculate a commutation in self commutation. We have to calculating current Is. So Is means Vs by so current will be calculated by voltage by resistance. Okay, here voltage will be Vs V minus Vs of 0 by S. Okay, S and R plus Cs. Okay, so here Cs into V minus Vs of 0 by S and division by RCS plus RCS plus and SLC plus 1 and C into V minus Vc of 0 by 2 and SC plus S plus 1. So V minus Vc of 0 by L by R and S square plus L plus S and this L by R plus 1 by L into LC. Okay. So V minus Vc of 0 by L and R plus 1 by L into LC S square plus S. So V minus Vc of 0 by L and division of total resistance will be R by L into 1 by LC into R by 2L into R by 2L. And after simplifying this, V minus Vc of 0 by L, S plus R by 2L and integration of 1 by LC minus R by 2L. Okay. So next. So here this V minus Vc of 0 by L and division by S plus R by 2L and plus integration of 1 by LC minus R by 2L. Okay. So by simplifying this, A by S delta square plus omega square. Okay. Here A equal to V minus Vc of 0 by L. So here this part we are taking A. Okay, and S plus delta. So delta means R by 2L and omega means 1 by so root of 1 by LC minus R by 2L whole square. So omega is called natural frequency. So I of S equal to A by omega. So A by omega and omega by S plus delta whole square by omega square. So taking inverse Laplace transform. So by taking inverse Laplace transform, inverse Laplace transform taking, so I of S comes to I of t and A by omega we have taken aside and 1 by S plus omega. So omega by S plus delta square plus omega formula will be e power minus delta t into sine omega t. So therefore expression for a current I of t equal to V minus Vc of 0 by omega L. So that implies, so A means V minus Vc of 0 by omega L and e power delta, so e power delta t into sine omega t. Okay. So therefore expression for a current I of t equal to V minus Vc of 0 by omega L and e power minus R by 2L sine omega t. Peak value of current equal to, so this is peak value of current V minus Vc of 0 by omega L. So at peak value of current when you are taking sine omega t. So sine 0, so omega will be at omega t will be pi. So a peak value means at pi value the omega will be so sine pi. So sine 180. Okay. So next expression for voltage across a capacitor at the time of turn on applying KVL into a figure. So when applying KVL, VC equal to V minus VR minus VL. So in the circuit, whenever we are applying KVL, so total voltage Vs equal to VR plus VL minus Vs. So that is, here we have written. So Vs equal to V minus VR minus Vs, Vc equal. So here we are calculating capacitor voltage. Vc equal to V minus VR minus VL, and Vc equal to V minus VR. Here inductance voltage L equal to di by dt. Substituting for in equation 1, V equal to V minus R into, here already we calculated R omega. So e power omega sin omega t minus L into d by dt of e power 2L sin omega t. So here Vc equal to V minus R into e power 2 omega by delta sin omega t minus L into a by omega e power delta t omega cos omega t minus e power delta of t sin omega t. Here we are applying, so here we are applying Laplace transform. Okay. So we are applying differentiation. So whenever we have differentiate this equation, so we have obtained this. After that, V equal to a by omega e power delta. We have, so e power delta t will be taking common, and r sin omega, here r sin omega t plus omega L cos omega t. So this minus will be multiplying, then it will comes to plus. So omega L cos omega t, and this minus L. So here we are taking E delta will be common. So L delta sin omega t. Okay. So Vc equal to V minus a by omega e power delta t into r sin omega t plus omega L cos omega t minus L into r by 2L sin omega t. Vt equal to V minus a by omega e power delta t r by 2 sin omega 2 plus omega L cos omega 2. Okay. So substituting for A already we know that A means V minus Vc by 0. Okay. So when we are substitute this, so this equation will be obtained, and Vc equal to V minus and V minus Vc of 0. So e power delta t by R by L sin omega t plus omega cos omega t. Here omega t means pi. Okay. So sin pi means 0. Okay. So V minus Vc of omega e power minus delta t, and sin omega t plus cos omega pi. Okay. So V minus Vc of 0 e power delta t. Here this will be 0, and only omega cos pi will be come. So cos pi means 1. Okay. So therefore Vc equal to V plus V minus of Vc of 0 to e power minus r pi and e power 2L. Okay. So for effective commutation, the circuit should be underdamped. Okay. So the underdamped means r by 2L and 1 by root LC. So with R equal to 0, the capacity initially unchanged, that is Vc of 0 equal to 0. Then I equal to V by omega L sin of 1 by root LC. So already we know that omega means 1 by root LC. Okay. So conduction time of SCRE will be pi. Okay. Therefore I equal to V by L root LC sin of t by root LC. That means V into root of C by L sin of 1 by root LC. Okay, and capacitor voltage will be turned off equal to 2V. So the waveform of above condition, once the LCR will be turned off, voltage across it will be negative voltage. Okay. So for self commutation, these are the waveforms. For current voltage, for current and capacitor voltage. Okay. Whenever we are taking a current, so at first the current will be at pi, the current will comes to 0 and the capacitor voltage will be at up, will be slowly. At first the capacitor will not conduct. After initial point, whenever we are giving a gate pass, then only capacitor comes conduction. Okay. And this is voltage across SCR. So the voltage will be conducting up to pi. After pi, the voltage the SCR will not conduct and comes to 0, and the SCR will be a turned off position. Okay. So the main arm of self commutation will be the current comes to 0 at pi. So the current coming will be 0. Okay. So this is our class today. So today we discussed commutation techniques. Okay, commutation techniques of SCR. Okay. So commutation techniques of SCR means so we have natural commutation, forced commutation, and load commutation. So in natural commutation, so what is meant by commutation means to turning off a thyristor, we are using commutation process. In commutation process, we have natural commutation, forced commutation, and load commutation. Okay, so natural commutation. Okay, so in natural commutation, the latching current will comes to 0 by naturally. So in load commutation techniques, we are using RLC load. So by using RLC load, by using we come to 0. Okay. So latching current will comes to 0. Okay. And next, forced commutation. In forced commutation techniques, we have so many techniques are there. First technique will be self commutation techniques. We are discussing self commutation techniques. Okay. So in today class, commutation techniques are we are discussed. So turning off a thyristor. So why will turn off a thyristor means so yeah, everyone have a end. So thyristor will be turned on, turned off. So if you want to turning on a thyristor, then you can turn off the thyristor. Okay. So this is the commutation technique. So natural commutation, forced commutation, and load commutation technique. Okay. So natural commutation techniques is also called as line commutation techniques or class F commutation techniques, and load commutation techniques or self commutation techniques is called as class A commutation techniques, and force commutation technique, resonant pulse commutation, complementary commutation, and impulse commutation. Okay. So natural commutation techniques will be used in phase control converter, line commutated converter, AC voltage controller, and step down cyclone converter. Okay, so load commutation or self commutation techniques will be used in class A commutation. So class A commutation. Okay. So this is our topic. So load commutation will be used in series inverter circuit. Okay. So natural commutation will be used in step down cyclo converter, phase control converter, and line commutated converter. So load commutation will be used in series inverter circuit. Okay. So forced commutation techniques, we have so many are there. Today we discussed self commutation techniques. Okay. So this is our class today. Okay. So natural commutation, load line commutation, and forced commutation. Natural commutation is called natural commutation is used as phase control techniques, and line commutation techniques is used in series inverter. Okay. And forced commutation techniques, we are discussing only one technique, that is self commutation technique. Okay. This is our class. Okay.